Hey guys, this is Hemant from Edureka. Today in this session we'll be addressing what is AWS. So without wasting any more time, let's move on to today's agenda and see what AWS has in store for us. So we'll start off today's session by discussing the different cloud players which are out there in the market, including AWS, and we'll see why AWS is a leader among them. Once we have established that AWS is the leader, we'll see what AWS exactly is and we'll see what are the benefits when you use AWS. After that, we'll be addressing the question, is AWS good or bad? So as an AWS expert, you might come across this question a lot of times, so you should know how to address this question. After that, we'll be discussing the AWS domains. So domains are basically the categories under which AWS offers its services. Once we're done with that, we'll move on to the AWS pricing section, wherein I'll be briefing you guys up on all the key points which are there in AWS pricing, followed by the AWS Free Tier, where I'll teach you guys how you can use AWS for free. After that, we'll be talking about the job roles that AWS has to offer you, and we'll see which job role suits you the best. And in the end, we'll be solving a use case wherein you'll be solving a real life problem using the knowledge that you'll be gaining today. So guys, this is our agenda for today. Are we clear with it? Alright, I'm getting some confirmations. So Sandeep says yes, Maria says yes, Neil, Saurabh. Alright guys, so let's move ahead and discuss about the different cloud players which are out there in the market. So except AWS, you have Rackspace, you have DigitalOcean, you have IBM Cloud, Microsoft Azure, Google Cloud Platform, you have Giant, Terramark, VMware. So all of these cloud players are the ones which are closest to AWS when it comes to the competition. But when I say they are closest to them, I might be exaggerating, because when you talk about AWS is way ahead in terms of the server capacity or in terms of the market share when you compare with the rest of the cloud providers that I've listed here, right? So let's see why AWS is ahead in the game when you compare with the rest of the cloud providers that I've listed here, right? So AWS is ahead in the game because of these three factors. First up is the market share. So AWS alone has a share of 31% in the global cloud computing market share as compared to the 69% of the share which is shared by all the cloud providers which are out there. Now the thing here to notice is that this 31% mark is not matched by any of the cloud providers which are out there, even Microsoft Azure for that matter. So Microsoft Azure has a market share of around 20%, which is way lower than 31% of AWS, right? So it is way ahead in terms of market share. Let's talk about server capacity. So AWS has a server capacity which is 6 times the server capacity of all of its competitors combined, which is a terrific number. So if you're a customer and you have a very successful application and you decide you have to make a move to the cloud, now AWS will be the safest bet for you, because AWS provides you with that kind of infrastructure on which your application can grow, right? So that is the reason AWS is still preferred. The third reason is the early start. So AWS came in a time when no industry or no company wanted to invest in the cloud computing market, right? It came in 2006 when there was no competition in terms of cloud computing. So AWS took the risk, Amazon took the risk in the cloud computing industry, and the rest became history. It is today the most successful cloud provider, and most of its revenue, when you talk about Amazon's revenue, 70% of its revenue comes in from AWS. So these are the reasons that AWS is still ahead in the game. So since now we understand why AWS is a leader among the other cloud providers, it makes sense to learn about AWS, right? So let's see what exactly AWS is all about. So AWS is a cloud services platform. So it's a platform on which Amazon provides its cloud services. So it offers its cloud services in different domains. It offers its cloud services in compute. It offers its cloud services. It offers its cloud services in storage. It offers its cloud services in database. So it offers cloud services in different domains that we'll be discussing in a while. But the thing about AWS is that these services can be mixed and matched to create any kind of infrastructure or any kind of application. So you can think of any kind of application, be it a healthcare application or a banking application or maybe a social media application. All of these applications can be created using the same set of AWS services. And guys, that is the beauty of cloud computing, right? So this gives you a gist of what AWS is all about. So let's move on and to discuss what are the benefits when you use AWS. So let's understand these benefits using an example. So say suppose there are two friends and among these friends one owns a business. So the other friend is advising this guy that why don't you upgrade your servers? So as you can see, he has a set of obsolete servers. But when it comes to upgrading, this guy has some genuine problems. He says, what about the migration? And he's worried about the cost as well. So when we talk about migration, so obviously when you're moving your application from an old set of servers to a new hardware, the whole configuration has to change. So even if the platform is changing, the whole code has to change. So it will involve a lot of time. It will involve a lot of investment as well, right? So migration was a problem. Now servers are not cheap, guys. Servers are very expensive. So when you're buying new servers, it will obviously involve a lot of cost, right? So these are two genuine problems that this guy has. So the other friend comes up with an idea. He says, why not use AWS? So let's see how will using AWS solve his problem. So when this guy uses AWS, so his total cost of ownership goes way down. Now because the thing about cloud computing is you don't buy anything, you rent it, right? So now you rent servers instead of buying. So your total cost of ownership is going way down. You are actually incurring a fraction of a cost that you were incurring earlier, right? So your total cost of ownership goes down. Second point is it is highly scalable. So your infrastructure on the cloud is highly scalable. You can scale up and down according to your requirements without buying any servers, right? So cloud computing follows a pay-as-you-go model. So if you're using 3 servers up for now and your requirement in the next 2 hours, maybe you require 6 servers. So you scale up to 6 servers and after 2 hours you scale down to 3 servers again. So in this case, you will be paying for those 6 servers only for 2 hours. You don't have to pay for the whole month, or you don't have to buy a plan for maybe a year or maybe a term, right? You just have to pay for whatever amount of time you used it for. So it is highly scalable as well as cost efficient. The third point is highly reliable. So if you talk about a cloud provider like AWS, so their sole job is to provide reliability. You should rely on them in terms of service. So AWS provides high reliability when it comes to your application's uptime, right? And if you look at the track record of AWS, they have been perfect, right? They are so confident in their infrastructure that they have hosted their own e-commerce website on their own AWS infrastructure. So if they can rely on their own infrastructure, let us rely on them too, right? Let's talk about the fourth point, that is the centralized billing and management. So in one place you can manage all your AWS resources or you can manage all your servers and you will be billed accordingly, right? In one place you get billed for every resource that you're using in the cloud, which is again awesome. So these are the 4 benefits that you get when you're using AWS. There are obviously a lot of benefits when you think about it, but these are the 4 benefits which come to your mind when you think about cloud from a perspective. So let's discuss the next section of today's discussion, that is AWS good or bad? So everyone has a perspective, right? So let's see how we can address this question. So guys, this is the world map. On this world map, we have plotted the AWS servers, right? So let's talk about a region. Let's talk about Africa. So if you can see in Africa, you don't have any AWS servers, right? Whereas in the US, you have a lot of servers. So let's talk from a customer's perspective. I'm a customer who wants to use AWS. Now I tell you, you are my AWS architect. Now I tell you that my user base is in Africa. That is, my application would be used by users in the Africa region. Now, for me, AWS might not be a good choice because there are no servers in Africa. But that does not mean that AWS cannot serve me. Obviously, AWS can serve me. But if you look at the servers, so say suppose we talk about this server, which is this much far from Africa. So the latency would be more. If you're hosting your application on these servers, your latency would be more. When I say latency, I mean the response time, because your servers are very far, right? But if you have a user base in say USA, so there are so many servers in US, right? So obviously your latency would be very less. So if I talk about the customer whose user base in the US, obviously AWS is the app choice for you. But if I talk about the customer whose user base is in Africa, whose application will be used more in the Africa region, AWS might not be the app choice for you, or AWS might be bad for your business, right? Why not choose a cloud provider who has more servers in Africa? So this is how you decide whether or not to use AWS, and this is how you can obviously give an honest advice to a customer who comes up to you and asks you whether you can use AWS or not. So guys, are we clear with what this slide conveys? Alright, I'm getting confirmations. Okay, so let's move on to the next section. So let's now talk about the domains in which AWS offers its services. So these are all the domains in which AWS offers its services. The first domain would be compute, then we have migration, security and identity compliance, storage, networking, messaging, database management tools. Let's take up each domain and discuss the different services that AWS has to offer in that domain. So the first domain is the compute domain. So the compute domain has these many services under it. So the first service is AWS EC2. So AWS EC2 is a resizable compute capacity in the cloud. So it is just like your personal computer with a fresh operating system installed to it, right? You can configure this computer to be anything. You can configure it to be a web server. You can configure it to be a worker tier environment. You can configure it to be anything, right? You have that kind of independence. And that is same is the case with AWS. When you ask for an EC2 instance from AWS, you get this kind of independence. You can configure, you're free to configure this server to be anything, right? So this is AWS EC2. Next up, we have AWS Lambda, which is a little different from AWS EC2. So it is an automated version of EC2, but with AWS Lambda, you can only execute background tasks. So you upload your code with the code of the background tasks. You don't have to configure anything. You don't have to install. You don't have to choose an operating system. You don't have to choose the firewall settings. You don't have to configure anything. You just have to choose the platform, the code that you will be working on. Say suppose you're working in Java. So you select Java and you upload your code and your code will be run accordingly. Right? So this is what Lambda is all about, but it only executes, it is only about background tasks. You cannot do anything else. Let's talk about a next service, which is the Elastic Beanstalk. So Elastic Beanstalk is, unlike Lambda, is used to host applications. It is again an automated version of EC2, which means you don't have to configure your firewall settings, you don't have to configure your environment. All of that is done for you automatically. So say suppose you have a website which is in PHP. So you select the PHP environment and you click on create, your environment is created, and then you upload your code and your website is automatically hosted for you. So it is that simple. But the reason people would use EC2 on AWS Elastic Beanstalk when they have to host applications is when the environment is not listed in Elastic Beanstalk. So AWS Elastic Beanstalk has a specific set of environments that it currently supports. So if you have an environment or if you have a requirement which Elastic Beanstalk doesn't cover, you're free to go back to AWS EC2 and configure everything for yourself, right? So the basic difference between EC2, Lambda, and Elastic Beanstalk would be that Lambda is used to execute background tasks, Elastic Beanstalk is used to host your application, and with EC2 you can do either of the two, but if you cannot do it using Lambda and Elastic Beanstalk, you would turn on to EC2, right? Let's move on to our fourth service, which is the Elastic Load Balancer. So the Elastic Load Balancer is used to distribute your traffic equally among all the instances. Now, why is it elastic? Let's talk about that. Say suppose you have 4 instances as of now, right? And your instances scale up to 5 servers or 5 instances. So now your traffic instead of 4 has to be distributed among 5 instances. And that is managed using the Elastic Load Balancer. Now, when I say you scale up from 4 instances to 5 instances, I'm basically talking about scaling. So I'm talking about auto scaling. So which brings us to our fifth service, which is auto scaling. So auto scaling scales up or down the number of instances automatically according to the metrics that you specify. When I say metrics, you can specify that whenever my CPU usage goes beyond 70%, launch an instance, or whenever my CPU usage goes below 10%, decommission a server or terminate an instance. So this is how auto scaling works. And with auto scaling, you definitely have to use an elastic load balancer because like I said, when you scale up or down, your traffic has to be distributed accordingly, right? So elastic load balancer has to be paired up with auto scaling. So this brings us to the end of the compute domain. Guys, any question, any doubt in any of the services? Now, our aim is not to learn about these services, but to get an idea what AWS offers its services in, right? So do you get the idea of what these AWS services have to offer us? Alright, I'm getting confirmations. Guys, am I teaching that well? You guys don't have any questions. Any question, guys? Anything that you want to know? Alright, no questions. Let's move ahead. So let's move on to our next domain, which is the migration domain. So the migration domain includes services like Snowball. So Snowball is basically a physical device which is used to transfer your data from your own data center to the AWS infrastructure. So it's as if you're using a pen drive to give movies to your friend instead of emailing him, right? So in traditional ways, if you were to transfer your data to the AWS infrastructure, you do that over the internet. But if you have a petabyte scale of data and you want to transfer it quickly, you would use Snowball. So this is it. This is what Snowball is all about. Let's move on to our next domain, which is the security domain. So in security domain, you have these many services. So the first service is IAM, which is Identity and Authentication Management. So it is used to control access to your AWS resources, which you grant to your users which are using your AWS account. So if there's a user who can only launch instances, you can give him that access. If there's a user who can only review instances, you can give him that access. So a guy who can review instances cannot launch new instances or delete instances. He can only review them. And that is the kind of access that you can give to your users. So this is what IAM is all about. Our next service is KMS. So using KMS, that is the key management service, you can easily create and control encryption keys. Now, when I say encryption keys, I'm talking about public key and the private key. So the public key is or resides with the AWS infrastructure, and the private key can be downloaded by you. Now this private key has to be kept very confidential and safe, because if you lose this private key, you cannot access your AWS resources. So this is what KMS is all about. Let's move on to our next domain, which is the storage domain. Before moving on to storage domain, guys, any questions regarding any of the services that we just discussed? All right, no questions. Let's move on to our next domain, which is the storage domain. So storage domain includes all these services. Let's talk about the first service, which is the S3. So S3 is the simple storage service. So in the storage domain, let's talk about our first service, which is S3. So S3 is an object-based file system. So an object-based file system, the only thing that you have to understand is that each file is treated as an object, right? So S3 is a highly reliable and available file system which you can use to host your files or serve your files to maybe a website that you're trying to host. The next service is EBS. So EBS is a block level storage which is offered by AWS, and this EBS acts as a hard drive for EC2 and is only used with EC2. You cannot use EBS individually. Whenever any service or whenever you launch an EC2 service or an EC2 instance, the operating system has to be installed somewhere, right? So that operating system is installed on EBS. The speciality about EBS is that it provides high input output. And that is the reason it is used with EC2, so that it can perform faster. Let's move on to our next service, which is the Glacier service. So the Glacier service is a low-cost archiving service. So if you have data which is not that frequently accessed, it can be stored onto Amazon Glacier. And obviously Amazon Glacier is cheaper than S3 or EBS. So if you have data on S3 or on EBS that you don't use that frequently, you can transfer that data to Amazon Glacier. Now the difference between Amazon Glacier and maybe S3 or EBS would be that the access time would be more. That is, the latency would be more in terms of Amazon Glacier. So if you were to access a file in S3 or in EBS, the access time for that file would be very less or would be in microseconds. But when you talk about Glacier, the time would obviously be more, because first of all, it is low cost. So it will involve magnetic tapes. So Amazon Glacier uses magnetic tapes to store your data or to store your archived files. And that is the reason it takes more time. So this is what the archiving service Amazon Glacier is all about. Let's move on to the next service, which is Storage Gateway. So Storage Gateway connects your on-premises in IT environment and this AWS storage infrastructure. So it basically acts as an intermediate between your application and your database. So it takes the snapshots of your database environment and stores it on AWS S3. And whenever there's any corruption which is encountered in your database, it takes that snapshot and replicates your whatever instance had been corrupted. So this is what the storage gateway service is all about. So guys, if you don't understand any of these services, it is fine, because we'll be talking in detail about each of these services when we reach to the specific module. For now, your aim should be just getting an idea of what each and every service is all about. Any doubts guys so far? Anything that you want to ask? Alright, Neil has a question. Neil is asking me, what is storage gateway about? Okay, Neil. So let's take a use case. Let's take an example here. Say suppose you have an application server and you have a database server. So the storage gateway service will fit between your application server and database server, and it will take a snapshot of your application server and your database server, and it will store that snapshot in S3. Now whenever your database experiences crash, or maybe one of your database servers is not responding, so instead of troubleshooting the problem, what storage gateway does is it takes the snapshot from S3 and replicates whatever part of your database is missing or whatever server of yours has been crashed. So it basically heals that server by going to the last known good state. And this is what storage gateway is all about. Now storage gateway can be used in your private infrastructure. That is when you have the database servers and the application servers on your own premises, and you can use it in the AWS infrastructure as well. When you have EC2 instances and say suppose you have RDS. So in that case it will be sit between EC2 and RDS. So you might not know about RDS. So RDS is basically, you can consider it as a database, right? And EC2, like I told, is compute service, so it's a server. So if EC2 and RDS are configured to interact with each other, storage gateway can sit in between them and can take snapshots, the same process, store it in S3, and whenever there's a corruption, it can take that snapshot and replicate whatever has been corrupted. So this is what storage gateway is all about, Neil. So Neil, is it clear to you now what storage gateway is all about? Alright, Neil says all good. Okay guys, so let's move to our next domain, which is the networking domain. So the networking domain includes all of these services. So the first service is VPC. So VPC is a virtual private cloud that enables you to launch your AWS resources in a virtual network. Now why would you want your resources to be launched in a virtual network is because of this reason. Say suppose you have some servers on your on network and you have created some instances in the AWS infrastructure. Now you want those AWS infrastructure services or AWS services to act as if they were on your own private network. So you can do that by creating a VPN to your virtual private cloud. Now for that you have to launch each of your AWS resources that you want to include in the same virtual private cloud. Once you do that, you can connect your on-premise servers or on-premise network to the VPC that you have launched your instances in using a virtual private network. So once you have done that, you can access your resources as if they were on your own private network, right? And this is what VPC is all about. Now let's talk about a use case. Now say suppose you have an EC2 server. So like I said, you have EC2 and you have database. Now a database is a separate service in AWS and EC2 is a separate service in AWS. Now if you want these two services to interact, these two services should be included in a VPC. So when you include these two services in a VPC, they act as if they are on the same network and hence they can interact. So now EC2 can interact with the database service and get whatever data it wants. Now this is what VPC is all about. Next up we have the Direct Connect service. So the Direct Connect service is just like a leased line. It is a replacement to your internet connection. So when you have an internet connection, obviously the speed is slow, right? But if you want a dedicated connection to the AWS infrastructure, you use the Direct Connect service, which is just like a leased line to the AWS world. The next service is Route 53. So the Route 53 is a domain name system which acts like any other domain name system except the fact that Route 53 is hosted on the cloud. So what a domain name system does is it redirects your traffic from your website name to the IP address where your website is hosted. The next service is CloudFront. So the CloudFront is basically a content delivery network which reduces your latencies by bringing in your website from a server which is far from you to a server which is near you, right? When I say latencies, I mean the response time. One way of explaining this would be if you have a server, or if your application or if your website is hosted in the US and your user is sitting somewhere in China and he wants to access that website, obviously the response time would be more if the website is being served from the US server only. But what if I can bring that website and store it in a server which is in China only? So if that server is near your user, obviously the response time will become less. And that is what content delivery network is all about. Let's move ahead and talk about our next domain, which is the database domain. So the database domain includes all of these services. So the first service is Amazon Aurora. So Amazon Aurora is a database that has been created by Amazon, and Amazon claims that the performance of Amazon Aurora is 5 times faster than normal MySQL service. Now, the cool thing about Amazon Aurora is that it can be used with using the same language that you use with MySQL. So if you have an application which is configured to work with MySQL, you don't have to change the code of your application. You just have to change the address of your database, and that is it. Your application can interact with Amazon Aurora as if it was interacting with MySQL. But at the same time, you're getting 5 times the performance that you were getting earlier. This is about Amazon Aurora. It's a relational database which is just like MySQL but is 5 times faster. Let's move on to our next service, which is the RDS service. So RDS is a relational database management service. So it's not a database, it's a database management service. So it manages relational databases for you. So when I say manage, it does tasks like updating, it does tasks like rollback, it does tasks like updating a security patch, updating your DB engine. So all of these tasks which are done manually are done automatically when you're using RDS service. Next service is the DynamoDB service. So DynamoDB is again a management service, but it manages non-relational databases, NoSQL databases for you. The next service is Elastic Cache. So it's a caching service in the cloud. So one way or one application that you can understand for Elastic Cache is that it is above the database service. So if you have users who are requesting the same kind of data, or the same kind of request is being queried again and again with the database, it creates an overhead on your database service because the same kind of data is being accessed again and again, right? So one way of reducing this overhead can be that you store that result in Elastic Cache. Instead of going to the database and querying the result is directly fetched from the Elastic Cache and served to whatever user had requested that query, right? So this reduces the overhead on your database as well as makes things faster. Cache is faster than database, right? So instead of querying the result, your result is directly given to your user, and hence this process becomes faster, and at the same time your database overhead is reduced, right? So this was Elastic Cache. Now let's talk about the next service, which is Redshift. So Redshift is a data warehouse service, that is, it is used in analytics. So it can feed in data from DynamoDB and RDS, and it can perform analysis on the data which gets received from your DynamoDB or your RDS. So guys, this brings us to our end of the database domain. Any questions in any of the services that we have discussed so far? Okay guys, so I have a question from Shubham. So Shubham is asking me what kind of database services are used in RDS. Okay, so Shubham, are you asking me what database engines are used in RDS? Alright, so Shubham, basically you have 6 database engines that are used with RDS. So you have Amazon Aurora, which is a database which has been created by Amazon. You have MySQL, you have MariaDB, you have PostgreSQL, you have Oracle Server, and you have the Microsoft SQL Server. So these are the 6 databases that you can manage with RDS. So Shubham is asking me, are these all relational databases? Yes, Shubham, these are all relational databases. And with DynamoDB, you don't use any database. It is a database in itself as well. So basically, when you go to a DynamoDB page, you just create tables, right? You have that option of just creating a table. You don't have to choose a database service. All right. So guys, any more questions? All right, everybody seems okay with whatever we have learned so far. Okay guys, so let's move on to our next domain, which talks about the management tools. So the management tools include all these services. So the first service is CloudWatch. So CloudWatch is an all-in-one cloud monitoring tool. So you can monitor all your AWS resources that you have launched using the CloudWatch tool. Then you have the Cloud Formation tool. So the Cloud Formation tool is basically a templatization tool. So if you have created an AWS infrastructure, you can templatize that AWS infrastructure and then launch that AWS or replicate that AWS infrastructure in different environments. For example, if you have launched an AWS infrastructure in your prod environment, you can replicate that same AWS infrastructure using CloudFormation in your test environment and your dev environment as well. So this is what CloudFormation is all about. The next service is CloudTrail, which is a logging service from AWS. So why do you use logging service? So basically, if you have an application and you get a bug in that application and you want to troubleshoot that bug, so that is when logs come in. So you can read the logs and you can track where that bug occurred and hence isolate the problem and hence fix it. So this is the reason you use logs, and that is the reason you will be using CloudTrail as well. The next service is AWS CLI, which is nothing but the command line interface. So it is a replacement to the graphical user interface that you use in AWS. So if a user is more comfortable with the command line, he can use the command line, or otherwise you always have GUI at aws.amazon.com. The next service is OpsWorks, which is a configuration management tool. So basically OpsWorks consists of layers and stacks. So layers are basically a different number of instances. Say suppose you have 7 instances which you have configured in a way. So you have 7 layers. So these 7 layers can be contained in a stack, and you can change a setting at the stack level and they will apply to the layers level as well. So if you change something at the stack level, it will automatically get changed in the layers level as well. So basically you don't have to go to each and every instance and change the configuration. You can change it using in the stack level, and that is the reason OpsWorks is used. You change in one place and the change is reflected in all the other places, right? So this is what OpsWorks is all about. The next service is the Trusted Advisor service. So it is a customized cloud expert. So the Trusted Advisor can advise you in terms of the security best practices. It can advise you on the billing of your AWS account. So this is what Trusted Advisor is all about. So this brings us to the end of the management tools domain. Let's move on to our next domain, which is the messaging domain. So in the messaging domain, you have the following services. The first service is SES, which is a simple email service. So this service is used to send bulk emails to a large group of user base. So if you're a company like us, wherein when we launch a new service or when we launch a new course, we have to notify our customers. So for a use case like ours, we would use the SES service, in which with a click of a button you can send the email to the whole user group. So the first service under the messaging domain is the SES, which is the simple email service. So it is a cost-effective email service in the cloud. So if you have to send bulk emails to a group of users, you can use SES. For example, in our company, we send newsletters every week, right? So we have a large set of customers that we have to send emails to. So we can use the SES service. So with the SES service, with the click of a button, you can send in bulk emails to whatever group of users you want to send to. Next up, we have the SQS. So SQS is a queuing service in the cloud. So whenever you have tasks that have to be executed in a particular sequence, that can be done using the SQS. Now SQS can also act as a buffer. When you have stateless systems which are not aware of the state of this other systems which are running in parallel, you can use this SQS, or you can call it as a buffer, which remembers all the tasks which are still to be done. So if the first server executes the first task is deleted from the queue and the second task is listed. Now whatever server, maybe the second server, the third server, or the fourth server, whatever server in the cluster now wants to execute the next task, can pick up the next task from the queue, execute it, and hence the task will be deleted from the queue. So it also acts as a buffer. The third service is SNS, which is a push service which is used in AWS. So SNS can be used to notify or trigger events. So the next service in the messaging domain is SNS, which is a push notification service. So using this service, you can notify other services or invoke other services to do tasks. So basically, SNS is used to invoke triggers, or is used to trigger events, on events in response to which other services perform. For example, it can be used to invoke a Lambda function, or it can be used to notify SES that it has to send emails. right? So this is what SNS is all about. So guys, this brings us to our end of all the services in AWS. Any doubts that you guys have in any of the services which we have discussed so far, I can repeat it again. Alright, so I'm getting confirmation. So Sandeep says no questions. Neil says all well. Maria says no questions as well. Okay guys, so since you guys have no questions, let's move on to our next section, which is AWS pricing. So in this section, we'll be discussing all the key points that AWS has to offer us in terms of its pricing. So the first key point is pay as you go. So AWS offers a pay as you go model. So like I gave you an example that if you use 3 servers for 2 hours, you will be just paying for those 2 hours, right? You won't be taking a monthly pack or an yearly pack. There is nothing like that. AWS charges you according to the hour. So whatever service you're using for whatever time, you get charged for only that time. Next up, we have pay less by using more. So it might sound a little bit confusing, but yes guys, it is true. So the more you use, you'll be paying less. So let's understand it through the diagram that we have created here. So if you're using S3 up to 50 terabytes of storage, you get charged at $0.023 GB per month. But if you exceed your usage beyond 50 GB, you get charged less. You get charged at $0.022 GB per month. If you even exceed 500 TB, you get charged even more less, which is $0.021 GB per month. So you are paying less by using more. So this is what this model is all about. Next up, we have save when you reserve. So whenever you save or whenever you reserve an instance, you save costs on it. Now, how much amount of cost can you save? You can save up to 75% when you are reserving instances. So let's understand it using this use case. So there's this lady who wants to buy AWS or who wants to rent the AWS resources. She doesn't know how many resources she needs and she doesn't know the time she might be needing it for, right? So she gets charged an X amount. But if she knows how many instances she needs and she knows the time period as well, you can see there's almost a 75% reduction in the cost. So basically it makes sense for you to reserve instances if you plan to use those instances for a longer term. For example, in our company, we have our website, right, which is hosted on AWS. Now our website is going to be there as long as our company is there, right? So it makes sense for us for reserving instances. But let's talk about you. Maybe like you guys will be doing demonstrations, right? So those demonstrations are for your own private purpose and you can delete them after say 5 or 6 hours or maybe 1 or 2 days. So it doesn't make sense for you to reserve instances, because when you have to reserve instances, you can either reserve it for 1 year or a 3-year term, right? So if you want to use an instance for say 3 months or 4 months, there's no point in reserving those instances because you will be paying more for them, because you will be paying for the whole year, but you'll end up using it only for 3 or 4 months. So in those cases, you can follow the on-demand pricing model. But in case, like I said, if you have a use case wherein you know that your instances will be used for more than a year, maybe 3 years or 1 year, you can go ahead and reserve your instances and you will save costs. So guys, are we clear with what save when you reserve means and the other key points, which is pay as you go and pay less by using more? Alright, I'm getting confirmations. Sandeep says all clear. Others, Neil says all clear. Alright, so Sandeep is asking me, are the terms fixed? Is it only for 1 year and 3 year? Yes, Sandeep, sadly it is like that. You can only reserve your instances for a 1-year term or a 3-year term. You don't have an option of reserving an instance for say 6 months or 7 months. Any other question guys? Anything that you want to know? Anything you want me to add? Alright, okay, so let's move on to our next section now. So let's talk about the AWS Free Tier now. So AWS Free Tier is of 2 types. You have the non-expiring free tier and you have the introductory free tier. So the non-expiring free tier includes services in which the usage for these services are replenished every month. And when they are replenished for the lifetime. There is no boundation as to till what time it will be replenished, right? So the services included in the non-expiring free tier includes the SES, it includes Lambda, it includes DynamoDB, and it includes CloudWatch, right? So this is what non-expiring free tier is all about. What usage are we talking about here? You have to wait for that because that will be discussed in detail in the AWS pricing module. But for now, I think this is enough. You should know what all services are covered in the free tier, right? So this was about the non-expiring free tier. Let's talk about the introductory free tier now. So in the introductory free tier, you have services like RDS, EC2, S3, and CloudFront. Now the thing about introductory free tier is, like I said, so you can use these services for free for 1 year from the time you have signed up on AWS. Let's take an example here. So with EC2, you have 750 hours free every month for the first 1 year. Now the thing that we have to understand here is that in totality you get 750 hours in EC2. So if you launch two instances at the same time or maybe at different times, so their times are calculated differently. So let's take, for the sake of simplicity, there's two instances are launched together, right? So if two instances are launched together, they will run for free till 375 hours. That is 750 divided by 2. Let's talk about three instances now. So it will be divided by 750 by 3, right? So basically every time you launch more instances, the number of hours gets divided respectively, right? And this is what the introductory free tier is all about. Also, not all instant types are covered in the free tier. The instant types which are covered in the free tier are labeled as free tier eligible. So you have to be very careful when you're launching instances, otherwise you might get charged, because you guys will be doing a lot of practice on AWS, so it is important to know what all services are covered in the free tier, right? So guys, this brings us to our end of the AWS free tier. So guys, any doubts in the AWS pricing section or the AWS free tier which we just discussed? All right, Maria says perfect. Neil says no question. Sebastian says all well. Alright guys, then let's not waste any time and move ahead. So let's move on to the next section in our session today, which is AWS jobs. So now we'll be talking about the different job roles that AWS has to offer us. So let's look at the job roles. So in AWS job, you basically have three roles. The first role is the role of an administrator, then you have solution architect, and the third one is the developer. So the role of an administrator is to provision, operate and maintain infrastructure or applications on the AWS servers. The role of a solution architect is to understand the problems from the users and come up with an AWS solution, which will include the apt services which will be used for that use case. So for this, you have to have in-depth knowledge of all the AWS resources. Only then you will be able to take a call on which services to be used, right? Third job role is of the role of a developer. So whatever infrastructure is developed by the solution architect, on that infrastructure you have to develop applications. So that is the job of an AWS developer. So let me recap all these three services. So basically a solution architect develops an infrastructure, the developer develops an application on that infrastructure, and the administrator provisions, operates and maintains that application on the AWS servers. So guys, are we clear with the job roles that AWS has to provide us? Now whatever background that you belong to, you can choose a relative AWS job role and hence proceed with your career path. So if you are someone who has been involved in architecting a lot of solutions, your role could be a solution architect. If you've been a programmer all your life and you want to pursue this passion of yours in coding, you can be an AWS developer. And if you have been a system administrator and you still want to continue administration, you can always go in for a system admin role. So guys, are we clear with all the job roles that AWS has to offer us? Alright, I'm getting confirmations. Alright, so Sebastian has a question. Are these roles, is there a need to be certified for these roles? Yes, Sebastian, as you would have noticed that this training is about certification, right? So we'll be talking about the AWS certification when we come up in our next session. But since you asked this question, let me clear your doubt. So the administrator role is actually, in terms of AWS, it's a SysOps role. So when you talk about certification, so that certification is called the AWS SysOps certification. When you talk about the solution architect, the certification is called AWS Solutions Architect. And when you talk about developer, it's called AWS Developer Certification. So these are the three certifications which come at the associate level. Then comes the professional level. So at the professional level, you have the Solutions Architect Professional Certification, and then you have the DevOps Engineer Professional Certification. Now, a person who wants to become a Solution Architect Professional, he has to first become a Solution Architect Associate. Only then he can appear for the exam of a Solution Architect Professional. Coming down to the AWS DevOps Engineer Professional, for that, the prerequisites are either being an AWS Developer Certified or being an AWS SysOps Certified. So if you are either of these, you can become DevOps Engineer Professional once you clear your exam. Good question, Sebastian. It's good that you mentioned it. Any other question, guys? All right, everybody is saying all clear. Okay, guys, so let's move ahead. So let's discuss a use case now. So now the problem statement is that we have to create a highly available fault-tolerant image processing website. So our use case is to host a highly available fault-tolerant image processing website on the AWS infrastructure in a distributed manner. Alright, so I've already created a website which basically renames an image and stores the image in a different location, right? So you just have to change the code for processing the image. Since it's a demo, I just put in the code for renaming the image and putting that image in a different location or wherever our file system is, right? So you can replace this code with the processing code and it will run in the same fashion. So let's see what all is required for this use case. So the following things are to be executed. First of all, we would be needing a server to host our website, right? Then we have to queue our tasks because processing an image would require queuing tasks. Then we need a file storage system wherein we can store our images, right? Then we need to invoke our resources. So there should be a service which should be able to invoke the different resources. Since ours is a distributed application, it should be invoked by other resources, right? Then comes the image processing and other tasks. So we don't want everything to be centralized at one place. So our Elastic Beanstalk or whatever service we'll be using would be hosting our application alone, and all the background tasks will be executed by some other service. In the end, we have to email the users as well. So whenever the image is added to the file system, a notification email will be sent to the desired recipient, whoever has been marked, right? So these are all the things that have to be done if you want a use case to work. So let's see how we can architect it using AWS services. So since we had to host a website, so like I said, in the compute section, if you have to host a website or if you have to host an application, you would use the Elastic Beanstalk if that platform is listed. So my website is coded in PHP and PHP is supported by Elastic Beanstalk. So we'll be hosting our website on Elastic Beanstalk. Now my website code is configured in a way so that it interacts with the queuing system and the file system. So it will upload the image to the file system and it will add the relevant tasks in the queuing service, right? So once my file has been uploaded in the file system, my S3 will notify SNS, or my S3 will trigger an event and SNS will catch that event, and it will in turn notify Lambda and SES that a file has been added, right? So when Lambda is notified that an image has been added, what Lambda does is it gets executed. It starts executing its code. The first thing that I have coded in my application is that AWS Lambda will check for all the tasks which are listed in the queue, right? So it will check for the tasks which are to be done, gets the first task, gets it done, gets the second task, gets it done. So this is how it works. Let's talk about, and also since SNS is also interacting with SES, so like I said, every time an image is added to my file system, I want a notify or I want an email in response to that. So that is handled using the simple email service. So guys, this is how we will architect our use case. We'll be using all these services. So guys, are we clear with why we are using these services? Why not some other services? Okay, let me recap. So we are using Elastic Beanstalk because we have to host an application and we have our desired platform listed in our Beanstalk configuration. We are using SQS because we want the tasks to be queued and be executed in a sequential fashion. We are using S3 because we need a file system. We are using SNS because whenever a file has to be added, it should trigger an event and execute two different services. So these two services are Lambda and SES. We are using Lambda because all we are doing is performing background tasks which are being carry forwarded from the Elastic Beanstalk. And we are using the SES because we want to be notified via email that a file has been added to my file system. So guys, this is the architecture for a use case. Anything that you want to add, anything, any service that you didn't understand, anything that you want me to repeat. Guys, any question related to whatever we have learned so far? All right, Neil says no questions. Sebastian says all well. Maria says she's excited. Good Maria, good enthusiasm. Anyone else? Okay, so everyone is giving me a go. Alright guys, so let's move on and get our hands dirty with the demo part, right? So this is our AWS Management Console, guys. Let's configure our services one by one. So let me come back to my page. So first of all, let me configure the SQS service, right? So the SQS service, like I told you guys, it's a queuing service. So let's create a queue first. So our SQS service is listed under the messaging domain. So let's click on the SQS service. Now we'll be creating a new queue. So click on create new queue. Now I want a FIFO queue because the task which will go first have to be executed first, right? For that, I'll be needing a FIFO queue. So I'll click on FIFO queue and I will name it as Lambda FIFO because that is the way I have coded it in my application, that it will be interacting with a queue called Lambda FIFO. And whenever you're creating a FIFO queue, you have to end it with the extension .FIFO, all right? So my queue will be Lambda FIFO.FIFO. So let's click on quick create queue. Alright, so my queue has now been created, so one task is done. Let's see what all services we have to configure. Now I have to configure the S3 service. So let's go to the S3 console now. So we'll go back to the AWS Management Console, click on S3. Alright guys, so this is my S3 Management Console. These are all the buckets which are listed. So now I have coded my application in such a way that whenever I will upload a file from my website, it will get uploaded to a bucket called Edureka Lambda 1. And whenever that image will be processed from the Lambda function, it will get uploaded to Edureka Lambda 2 automatically, right? So we have to create two buckets now. So let's create a bucket called Edureka Lambda 1. We'll click on create. Let's create a bucket called Edureka Lambda 2 now. Click on create. Now, like I said, I have to configure my first bucket, which is the bucket that I'm uploading my image to from my website, to notify the SNS service, right? So for that, let's first create an SNS service. Let's go back to the management console and click on SNS. We'll click on topics. We'll click on create topic. Let's give the topic name as Lambda invoke, right? So it's listed here. Let's click on create topic. So my topic has now been created. Now I have to add the subscriptions, right? So first of all, let's invoke this topic from S3. So let's do that. So this is the bucket that I have to configure to invoke SNS. So we'll right click on the bucket and click on properties. Now these are all the property that I'm interested in is events. So I'll click on events. Now what is the event that I wanted to do? So basically if I do any operation on an object, I should notify it. So if I click on object created all, so any operation that you do on the file will notify SNS. But since I am uploading a file, so let's click on put. So put basically means whenever a file is uploaded, you have to notify something, right? So the event is put. Now I want to send it to SNS. So SNS is selected by default. Let's select the SNS topic now. So my SNS topic is listed here. It's called Lambda invoke. So let's click on that. Now when I click on save, I'll get an error that it is unable to validate the foreign destination configuration. So what this basically means is your SNS is not configured to receive notifications from other services as of now. So we'll do that. We'll click on other topic actions and we'll click on edit topic policy, right? Now you have to select everyone here so that any service can invoke it, and we'll click on update policy. We'll go back to S3 Management Console. Now when I click on save, this event will be saved. Right, so this event is now saved. So whenever a file will be uploaded to Edureka Lambda 1, it will be notified to the SNS service. So let's go back to our diagram. So this is our diagram, guys. Now whenever a file is uploaded onto the S3 bucket, it will in turn notify the SNS service. So SNS service has to now notify AWS Lambda and SES. So for that, we have to first create the AWS Lambda service, right? So let's do that. So let's create our AWS Lambda function. Now the way you will be creating your AWS Lambda function is like this. Now you have to download an IDE called Eclipse. When you will download this, when you are configuring or when you're coding a Lambda function in Java. So I'm coding my Lambda function in Java. So I have downloaded Eclipse. Now Eclipse can be integrated with AWS SDK, right? So you have to download the AWS SDK for Eclipse to interact with the AWS services. Now how you can do that? You'll click on help and you'll click on install new software, right? Now you have to click on work with and you have to enter the name of a site. So let's enter AWS. So basically this is the address that you have to enter, which is https aws.amazon.com/eclipse, right? So when you do that, it will list all the packages over here. So you have to select all the packages and click on finish. This way all the SDKs which are required for AWS will be installed with your Eclipse, and then you will be able to use Eclipse with your AWS account. Alright, so these are all the SDKs which are listed. So you have to select them all and click on finish, and this way, so I've installed it already, so I don't have to do that. So my SDK is installed. Right now I have to upload, or I have to create a Lambda function. So for creating a Lambda function, I'll be doing it through the Eclipse. You can also do that manually, but since you have to upload code, so it's better to upload your code from Eclipse. This way you can also test it, right? So my code is this. So I'll be uploading this code and the documentation along with it in the LMS. So don't worry, I've explained the code over there. And you guys, you don't have to worry about the code, because all you have to understand is the architecture and how to deploy it, right? But anyways, I have attached the documentation with this code and I've uploaded in the LMS. So it's a simple code, you don't have to sweat about it. Let me show you some things in this code. So like I said, I have configured my code to interact with two buckets, which is Edureka Lambda 1 and Edureka Lambda 2, right? So my code of my Lambda function will pick the bucket, or will pick the file from Edureka Lambda 1, and it will drop the file in Edureka Lambda 2 after being processed. This is the queue that my code will be interacting with, which is Lambda FIFO. So let us check whether this is the same queue. So this is the link to the queue that will be interacting to. So let's go back to the AWS Management Console and click on SQS. So this is my Management Console. Let's go to the SQS Management Console. Click on Lambda FIFO, the queue that we have created. And this is the link that I've added in my code, right? So to be double sure, let's just copy this link and paste it in my code. Alright, so I have copied the link and pasted it in my code. So three things you have to configure in the code. One is the queue that will be taking the task from, and then the buckets that we'll be interacting with. Alright, so all is done. So let us now upload our code to the Lambda function. So for that, you'll click on the project. For my project name is Hello Lambda. So I'll right click on that. And once you have installed the SDK, there'll be entry over here, which will be AWS, which is Amazon Web Services. You'll point to Amazon Web Services, and these are the three functions that you'll get, right? So you'll click on upload function to AWS Lambda. Now, since we haven't created a new function, and it has auto selected it since there's no Lambda function as of now. So it'll create a new Lambda function and then upload the code onto it, right? So let's name our function to be something which could be SQS Lambda, all right? So let's name it this. We'll click on next. So basically this is the configuration. So let it be a default. You don't have to change anything. All right, let's click on finish now. So now it is creating the Lambda function, and once it does that, it will upload the code which we have in our Eclipse to the Lambda function, And once it has done that, this progress bar will close and we can hence proceed. Okay, while this is happening, let's go back to our management console and fix the other things. So our AWS Lambda function is getting ready, right? And our SES is still to be configured, and then we will be connecting it with SNS, right? So let's first connect the SES and SNS, and we'll wait for Lambda to be ready, right? So let's do that. Let's go back to our management console. So we'll come to SNS, we'll create a subscription. Now we have to check the protocol. So protocol is email, right? And the endpoint should be your email. So I'll put it as hemant@edureka.co. All right. So we'll click on create subscription. So now it says pending confirmation, which means I have to basically confirm. I'll be receiving an email from AWS that you have been subscribed to a topic. Do you want to receive notifications, right? So I'll go to my Gmail, and here it is. I've got an email from AWS notifications. I'll confirm the subscription. So it says subscription confirmed. So that means my email ID has now been confirmed. So let's go to our SNS and click on refresh. So as you can see, my subscription has now been confirmed. All right, let's create one more subscription. So let's first check our Lambda is ready. Okay, so the progress bar is now gone. So that means our Lambda function is ready. So let's just check it. If we can see our Lambda function, we'll go to the AWS management console. We'll go to Lambda under the compute section. So yes, there's a function called SQS Lambda which has been created. Alright, so let's go back to SNS, click on create subscription. In the protocol you have to select AWS Lambda, and that is it. You have to specify which AWS Lambda function you want to connect to. So you will click on endpoint and list all the functions that you have created. So ours is SQS Lambda. We'll click on it and click on create subscription. Alright. So both the subscriptions have now been added. So let's go to our diagram and see what all we have configured. So we have configured our SQS, we have configured our S3. Our S3 has now will notify whenever an put object or a put function is done in a bucket, which is Edureka Lambda 1. So whenever a file is uploaded to Edureka Lambda 1, the SNS will be notified, which in turn will notify AWS Lambda and SES. We have configured, or we have confirmed from our email that SES can notify us, and our AWS Lambda function, we have uploaded the code which can interact now with the SQS service. Then the SQS service will be uploaded from my website. So our website is left now. So let's create the environment first for the Elastic Beanstalk. So we'll go back. We'll go to AWS Management Console and we'll click on Elastic Beanstalk, right? We'll click on create new application. We have to name our application now, so let's name it as Edureka-Lambda, right? We'll click on next. So now it is asking me which environment do I want to create. So since ours is a web application, so we'll select the web server environment. Now my website is in PHP, so I'll select the PHP predefined configuration. So what basically this does is it will automatically install all the files required for running a PHP environment. And my environment type is load balancing and auto scaling. So since I want a highly available application, this is perfect for me. So I'll click on next. So let it be at sample application for now because I want to show you guys how you can upload your code. So let it be at sample application and then we'll select it to 100. Don't worry, we'll be explaining everything to you guys when we'll be reaching the Elastic Beanstalk module. But for now, since it's just a demonstration, the reason we are showing you all this is so that you get a feel of what AWS is and you can actually practice by seeing this video. So once you practice, you will have a lot of questions or you will understand a lot of things which theory can't do, right? So first practice, and if at all you have any questions, you can always ask me and email me. And obviously we'll be discussing everything when we'll be reaching this module, right? So don't sweat, don't panic. If you don't understand anything, it's okay. Change it to 100 and click on next. Now this is the URL that my Elastic Beanstalk will be pointing to, right? So if I click on this URL, I'll be redirected to my website that I'll be uploading on this AWS Elastic Beanstalk application, right? So we'll check for availability. If this URL is available, it shows green, that means it is available. We'll click on next now. So let's now create this environment inside a VPC. We'll click on next. We'll select the instance type to be t2.micro. The key pair is not required. Rest everything, leave it whatever it is and click on next. Environment tags we don't need, click on next. We have the VPC as C9, let it be. We'll select one subnet and the security group doesn't matter. Click on next. And permissions, let it be a default, click on next. Now this page is for review. We can review all the settings which we just did. So everything seems fine to me. So we'll click on launch. So my Elastic Beanstalk environment is now being created. This will take some time. So let me show you my application on localhost. So my web application is in a folder called test in localhost. So let's do that. So this is my home page, guys. So we'll choose a file to upload. We'll go to pictures. So let's upload a picture called desert. So once I upload this file should go and get stored in the Edureka Lambda 1 bucket in the S3 management console. So we'll click on open and we'll click on upload image. So my file is now being uploaded. If everything goes fine, my file will be uploaded in Edureka Lambda 1 bucket and my Lambda function will be invoked in this case. So it shows successful here. Let's go to S3 and check if our Edureka Lambda 1 bucket has been populated. So yes, a file called desert which I uploaded has been uploaded. So let's double click it and check if it is our file. So yes, this is my file. Awesome. So my file has successfully been uploaded. Let's check if the Lambda function executed and populated my Edureka Lambda 2. So yes, there's a file over there. This file has been renamed and it has been put in Edureka Lambda 2. Let's check if this is the file that we uploaded. So we'll click on open. Alright, so this is the file that we uploaded. So our Lambda function is working all fine, guys. So congratulations. If you are on this step, you're almost there, right? Your website is working. You just now have to upload it to your Elastic Beanstalk and you're all set, right? So let's check if our Elastic Beanstalk is ready. Alright, it's still in the creation phase. Alright guys, so now it is ready. Now I have to upload my code, right? So for uploading my code, there's a way. You have to click on upload and you have to upload the zip of all your code, right? So this is my code for my web application. And so let me quickly show you what all changes you have to do once you upload it to Linux environment, right? So mine is a Windows environment. So my environment is Windows, so there is no change. But when you upload it in a Linux environment, you have to change the paths, right? So in one section of my code, it says that I'll be basically auto-loading all the SDKs from AWS, right? So this path is that I've said I have to change this path. Now this is the path that has to be there when you are uploading it into a Linux environment. So I'll copy this path and save it in my code. Save it, go back in the folder. Now I have to zip all these files, right? So I'll zip these files, put it in a compressed folder, name it as upload. You can name it anything, there's no restriction on the naming part. Once it's been zipped, you can now upload it into your application or your environment, right? So this is my Beanstalk environment. Let me upload my code. So you'll click on upload application and you will go to the folder that you have stored your code in. So this is the file that I have just zipped. I'll click on open and click on deploy. Now it might take some time for your code to be deployed, so just be patient. And once it turns to green, that means your application is ready. Alright, so my Beanstalk is ready now. So it says green. So let's check if our link is working. So this is the URL that will point to your website. So let's click on this URL now. Alright, so my website is up and running on Elastic Beanstalk. Let's check if all the things are working fine. So we'll go to pictures. Let's upload one more picture. So I like penguins. Let's upload a penguin image. And click on upload image. So it says successful. Let's go to S3 and check. So our Lambda 1 is the bucket in which our raw files are uploaded. So let's see if our Penguin file has been uploaded over here. So yes, a Penguin file has been uploaded. Let's go back. So if our Lambda function executed perfectly, it should have uploaded a file in our Edureka Lambda 2 bucket. So let's see if our function is working. We'll click on Edureka Lambda 2, cross our fingers, and yes, it says 2 files. So let's be sure and check if this is the file that we have uploaded. So we'll click on open. So yes, this is the file that you uploaded, guys. So congratulations, you have successfully created an application, or you have learned how to create an application which is involving these many services. So we have basically created an Elastic Beanstalk environment now, which is hosting our website. Our code is interacting with the file system and the SQS. So basically it uploads a file and it lists down the tasks which are to be done in SQS. S3, whenever a file is uploaded, the bucket informs SNS that a file has been uploaded. SNS in turn invokes two functions or invokes two services, which is AWS Lambda and SES. AWS Lambda processes the image, takes the task, whatever is to be done from SQS, processes the image and puts it back into another bucket called Edureka Lambda 2. SES in turn sends me an email. Oh, I forgot to show you guys if I got an email. So let me go to my Chrome and go to my Gmail and show you if I got an email if a file was uploaded. So yes, I've got two emails since I uploaded two files, and these are the two emails. The first email tells me that a file has been uploaded to Edureka Lambda 1 bucket, right? And the file's name is desert.jpg. So the first file that we uploaded was the desert file, right? So this is that file. And the second email, which I've got just 1 minute ago, is that a file has been added onto Edureka Lambda 1 bucket and it's called penguins.jpg. Alright, so this is the email that I got, guys. So our SES is working fine again. So our SES basically sends us the email, AWS Lambda process the image, and this is what our application is all about, right? Any question, guys, any part of the demonstration which you didn't understand or want me to repeat, I can repeat. I just need a heads up from you guys. Any part of the application that you want me to repeat, any application that you didn't understand, any doubts, guys? All right, John says all clear. Neil is all clear as well. You're welcome, Neil. Guys, any questions? All right, so since I have no questions from you, let me wrap up the session then. So this is all what we have learned today. So first of all, we discussed what is AWS. So first we dealt with what is AWS. So I gave you guys the definition of what is AWS and what AWS deals in. And then we saw the different benefits that you get when you use the AWS service. And then we saw the different domains in which AWS deals in. So domains are basically the categories under which the services are there, right? So we discussed all the domains in which AWS provides its services. After that, we covered briefly the AWS pricing section. So we discussed all the key points which are there in the AWS pricing. And then we also shed some light on the AWS jobs portion, wherein we saw what are the different roles that AWS has to offer. And you can decide, guys, whatever field you are in, you can decide which role you want to get in, right? And in the end, we solved a problem. We had a problem in hand and we solved it using the AWS services. And this is it, guys. So guys, any doubt in whatever we have discussed so far, anything that you got in your mind regarding, even if you want me to repeat what is AWS, I'll do that. I just need the heads up from you. Any part that you didn't understand. All right, everybody is giving me a green, guys. Okay, so let's move ahead. So guys, this brings us to the end of our session. So thank you all for having the patience to go through my session, right? I hope you guys have learned something new today. So I'll be handing out the assignments related to today's session, and I hope you guys will solve it in the next session. Also, guys, please remember, do practice. So the hands-on that we have done today, it's a very big demonstration. It might look it's simple, but it's a very big demonstration. So you have to practice it. And once you practice it on your own, you will understand a lot of new things. You will have a lot of new questions that will come to your mind. You can always contact. So for that, we have our support team, which is there 24/7 to help you out. I hope to see you in the next session. And please complete your assignments and be prepared with the hands-on in the next session, because the next session is going to be more advanced than this session. So I want you guys to be ready. All right. So thank you guys for joining today's session. See you next time. Have a good day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!